that. I'm going to try to break it up a little bit and let you work. So we've got types of angles, right? Acute, I always think of one like that. It's less than 90. Anything less than 90 is acute. Obtuse, I think you know that one, right? Greater than 90 degrees. The right angle is our classic 90 degrees. A straight angle, this one is always overlooked, but the importance of this. But if a straight angle is basically, think of a straight line and cut it anywhere you want. Now you've split it into two, right? Two segments. If you were to measure from one to the other, that'd be 180 degrees. So think of like a hat, an RCMP hat, right? Reflex, I'm trying to think here. Reflex would be not the inside here, it would actually be the outside there. And anything greater than 180 degrees is called a reflex angle. Not going to happen very often, but that way you know. Okay. And the following properties are always true. I'm going to highlight this. These are going to be very important. You're going to use them a lot when you're asked to justify. Okay. Complementary angles. Okay, angles whose sum is 90 degrees. So if you have a 90 at the corner and you've got a 20 and a y, right? We can easily find angle y by going 90 minus 20. So angle y would be 70 degrees. So I think that is no news there. Supplementary angles, angles whose sum is 180 degrees. Okay, so let's say this is 30. If that's 30, but remember there's always a straight angle. There, you see the straight line right here? So you know, okay, I know that this is going to turn into a 180 if I just took the other side of this. Okay, this is 150 degrees. So combined, you get your 180. And this is the shortcut because I don't need you to always write it out though every time. I'll just say straight angles equal to 180. That's going to be, if you need to justify ever, like why did you do this? This is your shortcut right here. Shortcut right there. And you'll see it a lot, so I don't think right now it's super important for you to remember that. But there's, again, over here, do you see a straight line here? Yeah. Right now they're always like this, but keep in mind that this may be sideways. But a straight line, if you can draw a straight line, anything that touches that line forms the 180, okay? So angle X in this case, I'll just go 180 minus 31 minus 24. So I just subtract what's next to it, and I'm left with angle X. And that's 125 degrees. Okay. So remember, this could be inside of some ugly shape that you might encounter later on. But as soon as you notice that, it's like, boom, I got that, right? You got the 125, no problem. And all three combined would be considered supplementary. So let's do the justification. So if I asked you to justify, you just say straight angles equal to 180. That'd be the justification. To be honest, I don't really care how you justify. I just like to give you some tools to make it faster. If you want to write it out like a sentence, go for it. I think, though, it's not necessary. So still, next page, still everything is true that you find on the next page. So I'm going to try my best to give you lots of visuals with this unit because a lot of you said what helps you learn is visuals. And I'm going to try my best here. And the next one, vertically opposite angles are congruent. Congruent is the same as equal, okay? Here's the symbol for congruent. It's an equal sign with a third wavy thing there. With a third wave. Now you're thinking COVID, right? How many waves did we have there? I don't even know. Vertically opposite, you got to think of it this way. Whenever lines cross each other, make a point right there. And this one here, this angle right here, would be considered vertically opposite to this one right here. And guess what? The other ones would also be vertically opposite. Okay, so this one right here would be vertically opposite to this one right there. So if we go 1, 2, 3, 4, just like that, just put a number for the angle, you would say that angle 1 and angle 3 are congruent. They're vertically opposite. Angle 2 and angle 4 are congruent. They're vertically opposite. So you would know immediately, oh, they're crossing each other. I've got vertically opposite angles here. And this is always true. It doesn't matter what else we know. This is true no matter what. So look at the other one here. Yikes, right? What's happening there? Lots of crossings. Don't despair. Just kind of think of this line here. I'm highlighting just a random line that's going through there. And then this one here. It's easier to see. 29 would be vertically opposite to which one? Y, right? It would be vertically opposite to Y. How do you know for sure? The two lines that I highlighted, they continue on the other side. It's almost like a mirror, right? So angle Y, I put the angle notation whenever I can, is equal to 29 degrees. What about angle X? 35. There you go. Angle Z. Somewhat of a trick. 180 minus these two, right? Do you see that Z? There's a straight line here, and there are three angles along it. So we're just going to go 180 minus these two and then get Z that way. Okay, there we go. Perfect. So it's 180 minus 29 minus 35. That's 116. So I know it's getting tight there, but I'm just going to say the reason how I found that is straight angles are equal to 180. That's how I found that one in particular, Z. These ones here, how did I find them? I just used vertically opposite are congruent. This is the shortcut if you'd like it. Vertically opposite angles are congruent. That's all I need to see. And we know, everybody in this room will know, okay, that's what we're using. So if you want the shortcut here one more time, I'll just say vertically opposite angles are congruent. That's the shortcut. And if you want to make it a little longer, you go for it. I'm not going to be too picky with, is it exactly like that? I just want to see that you know what we're referring to, what property we're referring to. All right, more information here. Sum of interior angles of a triangle is always equal to, if I add up all the angles in a triangle, do you remember what that is equal to? It's always 180, right? And I know you're going to be like, duh, I know that. But trust me, sometimes we don't think of that, and it's going to be there. The importance of that one is very, very critical. Sum of interior angles of a quadrilateral is equal to, Quadrilateral is four-sided. Think of a square. It's four-sided, right? If you add up all the 90s, you get 360, right? It's always 360 for a quadrilateral. It doesn't matter what it looks like, though. If you could have the weirdest looking four-sided shape. If you add all of these up, right? 1, 2, 3, 4. That'd be 360. I know you're thinking that doesn't make any sense, but in this context, I think it does. Okay, so there we go. And some of you are gonna hate this part, the three-letter notation for angles. It's like, why? Why do we need to do that? If you want to refer to this angle right here, we would normally just say A, right? But what's the three-letter notation? Angle A is the same thing as using, you could go BAD, bad, right? And you can go the other way. You can go DAB, dab, right? Isn't that a thing? Dab, yeah. Bad, dab. Anyways, all of these are saying the exact same thing. Where every single time we're referring to that angle right there. And maybe you need to just, right, that is, see how that angle you actually were trying to refer to is always in the middle, and that is the pattern. It's not going to happen very often, but I really want you to know how to do that. So let's go the other way. Can you just use angle D? Would someone know for sure if you said D, which one you're talking about? There's two, right? That's where three-letter notation is critical. So this one right here, if you wanted to know what that is, let's give it a color. This angle would be angle ADB is equal to, just read it backwards, BDA, right? It's the same thing. So I'm going to highlight whatever color I used here. I'm going to highlight that. That's all I'm going to say there. Later on, I'll tell you, if I give you three-letter notation, I want you to go find it, find its location. We're going to put a letter or a number there and forget about the three-letter notation. Like once we know where it is, it's easy to just work with it that way. All of this is review, by the way. What about here? I want you to fill in the following, okay? So just copy this down. I thought of it too late before printing it, but I'm just going to ask you to find, actually put a number. All right, I want you to use this diagram and actually put numbers down here. And if you need to consult with your neighbor, that's fine. I'm not going to take too much time on this because I will review it later on again.